In this exercise, we're just going to look at some various exercises related to functions. Now, mainly in this question, we are going to look at the inverse function of a function, also domain and range. So the first part is find the inverse of this function, f of x equals 1 over 2x minus 5. So essentially what we want to do here is express in terms of x. Okay. And what I mean, this x here. So essentially we're going to arithmetically rearrange the entire equation such that we have x on its own. So what I'm going to do is get the reciprocal of both sides. Okay, so I'm just going to invert both sides. Or in other words, actually cross multiply both sides. So essentially what I'm going to do is have 2x minus 5 equals 1 over f of x. Okay, so that's a simple rearrangement. Okay, now what I'm going to do is I'm going to add 5 to both sides. 2x equals 1 over f of x minus 5. Okay, now so this is one expression here, and just to sort of make life easy, I'm going to sort of simplify it as 1 minus 5 f of x over f of x. That's just to sort of combine it into one expression there. Okay, so that is equal to 2x, and just to short there slightly. So then finally what I'm going to do is I'm going to divide both sides by 2. Okay, so I'm going to divide this side by 2, just get rid of that 2. And I'm going to divide the other side by 2. Essentially I could just put a 2 there. Okay. And essentially that is the job done. Almost. Okay. So x, that's in terms of it, expressed in terms of x. Now, the next part is what I have to do is replace x with f minus 1 of x and f of x with x. Okay, so that's what I have to do. So this 2 is gone. Okay, so my inverse function is f minus 1 of x equals 1 minus 5x over 2x. Okay, that is that first part. So yeah, you can check that there. Yeah, I'm going to move on from that. So we're going to move on to the next part here, part 2. Okay, and part 2 is a domain and range function here. So domain and range of f of x equals 7 plus 2 sine x. Okay. Now, essentially, this one's straightforward enough. This is question 2, or part 2. Essentially, what we have to look at is this part here. Sine of x, the output, the range of possible values. Sorry, just to actually first off remark, the domain of possible input values. There's no constraint here with 7 and 2 plus sine x. So essentially, we can have any input into this sine x function. So the domain is the set of all real numbers. That's not a spelling mistake, it's just a sort of slip of the pen. So the domain is all real numbers. So you can write it like that, or like that. Okay, so the course I'm teaching, the second way of specifying the range of real numbers is accepted. The range is as follows. Now let's just look at this part here, sine of x. So it's a sort of, if you're following the, if you're sort of like familiar with trigonometric functions, you'd know that the range of possible values of sine of x and cos of x is always going to be -1 to 1. Okay, so for 2 sine x, the output, the possible range of possible outputs is going to be minus 2 to 2. So essentially just double the value, the output of sine of x. Double the value of the output of sine of x. And then when we add 7, essentially what we're going to do is just add 7 to both of those. So what we get is 5 and 12. That is the range of possible values. And again, it's 9, 5 and 9. Okay, not 5 and 12, 5 and 9. I was just thinking of another one in my head. Okay, so that is 7 minus 2 and 7 plus 2. Okay, and the correct notation here is square brackets, because you can evaluate this function and get 5, and you can also evaluate this function and get 9. Okay, so moving on to the next one, part 3. So we're back to the inverse. So f of x equals the square root of 2x plus 3. So what we have to do is find the inverse of this. Okay, so what I'm going to do is square both sides. So f of x squared equals 2x plus 3. Okay, so I'm going to subtract 3 from both sides. So f of x squared minus 3 is equal to 2x. And now I'm going to divide both sides by 2. So I'll just do that here. Divide that side by 2 and divide that side by 2. So f of x squared minus 3 over 2. And again, what we do here is replace f of x with x, and x, replace that with f minus 1 of x. Okay, so the ultimate overall answer is x squared minus 3 over 2 equals f minus 1 of x. So that is the answer we are looking for. The inverse function is x squared minus 3 all over 2. So number 4 is also inverse. Okay, so what we are asked to find the inverse of this one here, e to the 3x. Now this is the one where the use of logarithms comes in very handy. So what I'm going to do is get the natural logarithm of both sides. Okay, so the natural logarithm of e to the 3x. If you know your logarithm laws and exponential laws, you sort of know that these are essentially cancel each other out. They're invertible, the inverse functions. Okay, so essentially that actually works out to be e to the 3x. Or sorry, 3x. Okay, so just to be clear what I mean by that, ln of e to the a is always equal to a, and likewise e to the ln of a is also equal to a. So that's very handy to know. Okay, so anyway, let's go back to this question here. So the natural log ln of f of x is equal to 3x. Divide both sides by 3. Okay, so divide that side by 3, divide that side by 3, and then just to finish it off, let's make some room here. To finish it off, what we'll do is just replace again x with f minus 1 of x and f of x with x. So replace f of x with x and x with f minus 1 of x. Okay. So again, let's just be that's the answer to the fourth one there. Okay. Now again, let's just be crystal clear. I specified it there. Replace f of x with x, and replace x with f minus 1 of with f to the minus 1 of x. Okay. So there's two more. Domain and range of one is a domain and range. So let's go to the end here. So this is number 5. F of x equals 1 minus x squared. Okay. Now domain. The domain here is all possible. There's no constraint on the possible inputs. Okay. The only time you really see constraint is when you get a square root or something like that. where it has to be positive. The output of the square root function has to be positive. Anyway, that doesn't exist here, so the domain is all possible real numbers. And again, just in case you're wondering, complex numbers aren't part of this course. Okay. Also denoted as R. Okay. Now the range is a bit more interesting. So the range, let's look at this part here. X squared, that is always going to be a positive number. Okay. But when you have minus x squared, essentially the output of this part is always going to be negative. X squared is always going to be positive, so minus x squared is also going to be negative. Okay. Now, what would happen if, for example, x was 0? Well, we could have 1 minus 0 squared, f of 0, and that would be 1. Now, essentially, the highest possible value that this output could give is 1. It can't get any higher. Okay. If we have minus 1 squared, we get 0. If we have 1 squared, we get 0 overall. 1 minus 1 and 1 minus 1 squared, which is 1 minus 1. Essentially, it's not possible to get a value from this function greater than 1. Okay. And again, 1 minus, it's because it's 1 minus something here. So, essentially, the highest possible output that this function can give is 1. It can give any negative number, so it can give 1 minus 100 if the input is 10. Let's just actually try that. F of 10 equals 1 minus 100, that's x squared, that's equal to minus 99, and so on. So essentially what I'm saying is that the highest possible output is 1, but you can get any negative number. Okay, so the range is minus infinity to 1. Okay. Now, again, just be careful that you understand the difference between the round bracket and the square bracket. It doesn't look particularly square, in that the round bracket is non-inclusive, but we always put it beside infinity and minus infinity also. And the square bracket means that it can include the term beside it. So this range of values can include 1. So the output here can be 1. So we have a square bracket there. Okay, finally, the last one here is number 6, and again, this is domain and range. Okay, and what we're doing here is f of x equals the natural log of x. Okay, now let's just remember a little bit about natural logarithms. So what I'm going to do is use some examples here. This is just logarithms. This applies to all functions, actually. It's not just the natural logarithms, all logarithms. These examples. Log to the base 2 of 8 is 3. Okay. Log to the base 2 of 1/2 is minus 1. Okay. You can get log of 1. Log to the base 2 of 1 is equal to 0. Or 0. Okay. So you can get any output from a logarithm. Okay. You can get, I just accidentally rubbed it out. You can get a positive number, negative number, and 0. So the output, you can have any real number. So the range is minus infinity to infinity. Now you can try this out with your calculator. I sort of skipped past the domain. Okay, so what's going to happen here is that you cannot actually have try this out with your calculator. Try get the log of any log of a negative number. It won't work. So it only actually works for positive numbers. Okay, you can only get the natural log of a positive number. Okay. Also, you might actually notice that you can't get the log of 0. Okay, I better actually check that in my calculator just to make sure not make a liar myself. Well, actually, when I do it, I get, sorry, just gone out of shot there. Essentially, I just brought my online calculator up. You actually get minus infinity. So, essentially, what I'm saying is that any value greater than 0, okay, but not including 0, up to infinity, okay. And again, 0 gives us correctly minus infinity. I'm just not accepting that as an answer, okay. So, it's So round bracket, we're not including 0, and all the way up to infinity. Anyway, I'm going to leave there. That is questions on functions, inverse of functions, domain and range of functions.